I thought it might be a good idea if I left up my registration info from advisory, because I didn't know if any of you guys had questions about registration. So, I mean, it partially depends on what grade you're in, obviously. You know, if you're in 12th grade, it doesn't matter. Although, if you're going to be in a major that is going to require calc, so for current seniors here, unless you get a 5 on the AP test, honestly, I'd recommend you take Calc 1 over again at college. And the reason for that is because a lot of your major is based off of Calc. Just ideas in Calc are part of a lot of things you're going to do. And so the better understanding you have of Calc 1 would help you a lot in your major. Not only that, there's a good chance you're going to get an easy A because you've already learned it this year. And even if you don't feel like you've learned it very well this year, because, you know, that's a common feeling leaving Calc. Like, it's not always a feeling like, even if you do well in the class, you might not feel like you understand it, right? Like, you can do problems, but it doesn't mean you understand them. Taking the class a second time, there's a good chance that when you start seeing problems the second time, all of a sudden it just clicks, and you'll kind of get them. And I've had countless number of students over the years talk to me after, you know, they've gotten into college and said that their college calc experience went great because they had a chance to take it here at high school first. And these were typically the students that I have that don't do well in calc. You know, and that because they kind of struggled, but they worked hard and they made it through the year. And then when they took it at college, they had a great experience because it kind of made sense then. You know, you don't have to spend 75% of your time worrying about how to do a problem. You kind of know how to do a problem. Now you can use your brain power to figure out what's going on. But for current juniors, you kind of have 3 options. I'd say a majority of you are just going to sign up for Calc BC. And Calc BC basically repeats Calc 1 in first trimester, so you get to review all of it again. And then you do new material for trimester 2. And when you take the AP test in Calc BC, you get 2 scores. You get a Calc AB score and a Calc BC score. And if your Calc AB score is better than the one you earned this year, it will replace it. Now, you also have other options. You don't have to sign up for Calc BC. One option is you can sign up for AP Stats. Like, maybe you just want to change on the kind of math you're trying out. You know, just want to see what you enjoy. You can sign up for AP Stats. There are also students that sign up for both. You know, and obviously that's a lot of work, but you can sign up for both. I've also had calc students who, as a junior, realized that calc was not for them. You know, they realized that a career in math wasn't for them. And honestly, you know, maybe you were taking calc because your parents kind of wanted you to. And you realized that the field you're going to go into isn't going to need calc. And so you could possibly take CIS algebra and get your credit at the University of Minnesota for college algebra. Because if your major only needs college algebra, that counts. So you guys have options. Technically, you don't even have to take a math class either, because you're already made your requirements. So do any of you guys have questions on registration or anything? I see. You guys are very talkative this morning. It's going to be one of those days, huh? Okay. It's Friday. You guys should be pumped up, jazzed up, ready to go. Okay. So I do kind of need a question that I need you to answer here for this. Normally during class, do you guys write down the problems in your notebooks, things like that? Okay. I assumed a lot of you did, and I'm not trying to guilt you into doing it or anything. What I was going to say is today's going to be really difficult to do that because today's topic is going to be a lot with graphs. We're basically covering 3 topics. The first and the third topic are all about graphs, and so it's going to be really difficult for you to write them down and me be able to do all the problems during the hour. So I don't know what the best option would be. Maybe taking screenshots of it or something, or just, watching the video later and writing them down. But I think for us to be able to get through all the material, you're going to almost kind of have to not write down the graphs because it would take too long for us to do. And I don't like that idea, but that might be what we have to do. So let me, oh, go ahead. Oh, I do that every day. Yeah. Yeah, I record every meeting we've ever had, and I put it on, I post the link on the day's folder later in the day. Also, if you guys go into the resources folder, that's also where I post all of them as well. Oh yeah, yeah, you guys can, I record every single meeting for if somebody misses a day or whatever. Okay, so our next topic is called accumulation functions. And my computer's working weird today. This is not a great sign. So accumulation functions run from the idea that you're finding the area under the curve from a constant number to x. And then this has to be a different variable than x. So we haven't talked about how to actually evaluate definite integrals. That's going to be for Monday. But what we have talked about is for definite integrals, these two numbers, the a and the b, represent where you're going to look to find the area under the curve. So for example, if you can read this, it says the integral from -1 to x for that graph. Well, then what you're going to do is you're going to imagine imaginary line, going like that. And if x represents 3, right? Oh, actually, I take it back. Down at the bottom of the picture, there's a 4. If f of 4 would represent, you're going to put a 4 in place of x. And so that means you're going to find the area under the curve starting from the number it gives up to the number you plug in. And so if f of 4, in this case, would mean that we're finding the area from -1 to 4. And you can calculate this however you want. Basically, these are all going to be geometric. So I see a rectangle that is 5 by 6, so that's 30. I see a rectangle with 6 squares, and then I've got a triangle that's 2 by 2, so that would be area of 2. So for this particular problem, the answer would be 38. An accumulation function is basically just, it gives you a starting value, so that's what c is, a constant. So that's going to tell you where kind of your beginning line is. And then the value that you put in place of x tells you how far you're going to find area. So for this particular problem, f of 5 would mean, that's a bad color to pick. F of 5 would mean that you're going to add these squares along with it, because you would go to x equals 5. So 1, 2, 3, 4, 8. 8 more. So f of 5 would be 46. This is what's called an accumulation function. The notation is usually what scares most people. So when you see this notation of an integral from a number to x, h of t dt, it looks kind of scary, but all it's telling you to do is find the area under the curve. And so we've talked about that part, especially with estimation of rectangles, and these questions are all going to be geometric shapes. So here, let me put a different one up. This is where I was saying I think it'd be really hard for you guys to write these down and catch up. So for this one, it says let h of x be the integral from -1 to x of g of t dt. And if we look at our picture is g of t. Because we can see there's a t there instead of an x. G is just a bunch of straight lines. The -1 on the bottom refers to the fact that that's going to be kind of like our beginning point. And whatever we put in place of x is going to be where we're going to find the area up until. So h of 3 would mean that we want to find the area up to 3. And these are all going to be able to be done with geometric shapes, usually rectangles and triangles. So I can do it like this, I guess. So then that's going to be 4 by 3, 12, 2 by 2, and then this is a 2 by 2 triangle. So we'd have an area of 18. Why don't you guys see if you can find the answer to this one? See if you can find the answer to this one. If it's too small to read, I can write it bigger for you. Lauren, how about you? Do you think you could describe to me what we're trying to do? Go ahead. I was going to say I don't even want the answer. I just want if you could tell me what we're trying to do. Okay. Where does it start? Okay, good. So -4 to -2. I mean, I guess this one isn't as bad as I was expecting because I was expecting it over there. So 6 by 2 would be 12. 1 by 2 would be 1. And this would be a half. So we've got 13.5 as the answer. The one question I was kind of surprised. So I went and looked through a lot of these examples in Khan Academy to find the different kind of questions. The one that I didn't find that I'm surprised about I'm a little halfway surprised nobody even asked me this yet, actually. If we are starting at -1, what happens if it asks you to find the answer before -1? So in this instance, -4 is before -1. But -1 is kind of like our starting point. And so that's why I was really surprised this wasn't in That was actually a terrible pick because it doesn't cross at a very good spot, does it? Well, whatever. It's a trapezoid. We can figure it out. What's going to happen if your second number is before the first number is the answers are negative, which is kind of weird because we're talking about this as area, and area can't be negative. So depending on the context of the problem, sometimes you can't have negative answers and they would be just positive. But if all you're told is the integral from -1 to a number before -1, the answer is going to be the exact opposite. So for like this one, what do we have? We have a trapezoid with a base of, I can't tell. I'm going to approximate this. So we've got 5 and 2.5-ish, but it's more than 2.5. So the middle between 5 and 2.5 is 3.75-ish by 3. Good God. We're going to say roughly -12 squares. That's not even right, is it? 9, 10. Yeah, we'll go with roughly -12 squares. So if you get a number that is before your bottom number, I just want to make sure that you know that the answer should be negative. But I did not see any examples of that in Khan Academy, so you very well may not need to worry about that. But like I found out yesterday, even with me looking through a bunch of examples, I don't even come close to seeing all of them. I just know that on the AP test, you will get some with negatives. How about this particular topic? How is this? How do you feel on this one? Like just really quick 0 to 5s in the chat. That kind of tells me if I should do some more or if I should move on. Okay? That seems to work well, having people put the number in the chat just so you don't have to say it out loud and things. Okay, then I'll move on to the next topic. Basically, the 3 topics we're doing today aren't big in calculus as an idea. What they are is they're definitely going to be on the AP test. So I'm making sure to take like a whole day to go over these types of questions because they're not horrible. They're just different than regular questions you're going to see. And so they're popular questions for the AP test because of that. I'm having a mind blank here. I believe this is called the fundamental theorem of calc. I don't know why I can't think of this right now. I'm pretty sure this is what this one is called. And the idea behind these problems is who should I go with? Why do we have so few people today? Chidera. Do you remember what I told you this symbol stands for? I think I probably told you a couple different things. Okay. Just for anybody then. Does anybody remember what this stands for? It is the integral symbol. What is the integral? Like, kind of. I mean, like you guys are saying correct things. So this symbol, we refer to it as the antiderivative because it stands for the opposite of a derivative. So derivative, a lot of people in their heads will think of going down in powers. I mean, derivatives actually mean the rate of change. So, but in your heads, a lot of people will think of derivative as like going down. An antiderivative means when you are given a rate of change, you want to find the function that it came from. So it's an antiderivative because you're trying to go backwards. Well, what the fundamental theorem of calc is if you are asked to take the derivative of an integral. Sam, what should happen if you take the derivative of an integral? What happens when we take the square root of a squared? Yeah. Yeah, when you kind of do two opposite actions, their effects essentially cancel each other out. So if we take the derivative of an antiderivative, we're back to kind of where we started. So the fundamental theorem of calc is if we take the derivative, what happened to my pen? If we take the derivative of a definite integral, so the derivative of a normal integral, that's nothing, that's easy. But the derivative of a definite integral, which I know you don't know the details of this yet. That's why teaching this first is kind of weird for me. What happens is it's still the same idea where the derivative and the integral cancel each other out. You're left with, oh shoot, I wrote a dx. dt. What happens is you're left with the original information. So the answer from this would be f of x times the derivative of x. So that's going to be the fundamental theorem of calc, and there's definitely a much more mathematically correct way of writing it. But I wanted to write what happens. And you guys are just going to have to trust me on why this works for right now. I could prove it if you already knew how to calculate things. So just kind of take my trust on this for right now. So let's look at the example I have written on the left. G of x is the integral, or the antiderivative, from -1 to x of 8 minus t dt. We're asked to find g prime of 1. Well, that's going to require us to find g prime of x first. So g prime, it is inferring or implying that you need to take the derivative of that integral. So the answer is going to be 8 minus x times dx. Chase, what is the derivative of x? Perfect. So g prime of x is 8 minus x. Our question that we're asked is what is g prime of 1? It'd be 8 minus 1. These questions are going to be very easy when you know what to look for. They look very scary if you don't. Let me put up a couple other examples. And you'll find that it does not take long to do these at all. I'm just going to put a handful of them right away. dx the one that I underlined right here, just the derivative of 1x is 1. So this is like actual derivatives from like when we did last trimester. I know 100% I get how it's going to look confusing because we write dt and we write dx and we don't do anything with them. For these particular problems, we're actually going to do the derivative because we're kind of like told what variables to use. I get that it's just kind of strange that, you know. Okay, I've got 4 problems up there. Varying degree of difficulty. Let's do the first one together. G of x is the integral from 0 to x of cosine of t dt. Oh, I totally ignored one facet up here. That bottom number doesn't matter. 100% useless. You'll find out why eventually, but that bottom number doesn't matter at all. So g of x, the integral from 0 to x cosine of t dt, find g prime of pi. G prime means that we are taking the derivative of that equation. So the derivative of the integral is going to be cosine of x times dx. Again, derivative of x is just 1. So g prime of pi would be cosine of pi, or negative 1. Questions on that one? Why don't you guys try the second one? The derivative and the integral symbol cancel each other out. And so we're left with this info. The only catch is that whatever the variable is up here gets plugged in place of that variable. So we don't take the derivative of this function because the original problem said find the integral of cosine. So if you think of cosine as starting point, the integral of cosine would be up here. And then we were asked to take the derivative of up here, which would turn back into cosine. So I don't know if that helps clarify it, but that's the derivative is canceling out with the integral symbol. Kennedy, did you figure out g prime of x? Okay. So g prime of x is having us take the derivative of the integral symbol. These two symbols cancel each other out. So the derivative of an integral is going to leave you with this information that's right there. Because those two symbols kind of are the same as like saying squared and square root. They're opposites, and so they counteract each other. So you would be left with, whatever variable was on the integral symbol. So instead of 5t squared, it's 5x squared. Instead of minus t, it's minus x. Instead of times dt, it's now times dx. And then the derivative of x is something we can calculate, because that's 1. And I'm going to guess you were not alone, Kennedy. That's kind of why I just started explaining it again. Ariana? Once we figure out g prime of x, just kind of a quick refresher, how do we find g prime of 2? Okay, so 5 times 2 squared minus 2 would give us 18. Now, running into this purple one, we're asked to find f prime. So that means we're asked to take the derivative of the integral again. Those two things counteract each other. So what we're going to be left with is the original function, but with 3x being plugged in place of t. So instead of it saying times dt, it's now going to say times d3x. So our final answer for f prime of x is going to be square root of 15 minus 3x times 3. So whatever variable function is on the integral symbol, that's what's going to be plugged in instead. So that's kind of why I took the time over here to talk about dx and dx, because now it's the derivative of 3x. So when we're asked to find f prime, oh, this one didn't ask us to find f prime of a number. Why? I didn't even notice that. So I guess this is our answer. How is this? I'm kind of getting the feeling that this is semi-confusing. I mean, is there certain questions I can kind of answer on it that's you're getting confused where the information's coming from, anything like that? Okay. I mean, if nothing, why don't you try this last one in pink? If you can get the last one in pink, then chances are you understand this pretty well. So I purposely tried to pick a more complicated one for the last one. Oh, so because the original problem already stated this constraint, you don't have to worry about it for the derivative, because the same constraints follow with the derivative. Yeah, and this was specifically listed so that there couldn't be any negative values for the square root. Cam, how about you? Did you get an answer for this pink one? Anything? Or do you have an answer you're not sure of? Did you get the first part? Or is this just kind of confusing all around? Okay. Even if you are flat out wrong, what did you write down? I'm not sure what you mean by that. Are you talking about like this cancel? Yes, yes, that one does cancel. And then you'd be left with this. But instead of a t, you're going to write square root of x. So 2 square root of x times derivative of square root of x. So that's going to be kind of like the order that this always happens, that this derivative and this integral sample cancel out, and then you're going to plug whatever function is there, even if it's easy like the first two, in place of the variable that's there. So like for this one, the derivative of square root of x is probably the hardest part of the problem. And then that would be, yep. So x to 1/2, the derivative would be 1/2 x to the negative 1/2. And what actually happens, the 2 and the 1/2 cancel out and make a 1. The square root of x and the x to the negative 1/2 turn into 1. So this one just basically has a lot of canceling. But the part that I was really worried about, or not worried about, but the part that I really was hoping you guys, oh, the highlighter works terrible on the black. I was hoping you guys got that line right. Do you guys want me to put up another example to see if maybe you can get that one? Because I got some more. Okay. Eric, how about you? Even if you're not done, if you could kind of just walk us through it. Do you think you could do that? Okay. Perfect. Close. Okay, go. Yeah, you're right. The part you forgot was the 3. Perfect. Perfect. Yeah, maybe there was a glitch in the internet too and I didn't hear it or whatever, but correct. So 3 cosine of x times negative sine of x would be negative 3 cosine sine. The order you write these doesn't matter. Perfect. If you guys got that, that'd be great. These don't get more complicated. They're strange problems, and there's not much more to say to that. Once you start learning definite integrals more, these probably will make more sense. But okay, let's kind of move on from there. I think you'll understand it better as you do more examples of it. And then now we're back to graphing, which is where I was saying it's really hard to take notes on. So these style questions are going to be like interpreting graphs of fundamental theorem of calculus. And these are they're super popular on the AP test, and so this is where a lot of students get stuck, so that's why I thought it'd be good for us to just flat out go over them together. So I've got some various types of examples, and we'll just walk us through it. So it says this is the graph of f, which starts off trying to make you feel like it's, not much at all. Down at the bottom it says let g of x equal the integral from 0 to x of f of t dt. Well, okay, so this graph is f of t. Or f of x, it doesn't matter. What is an appropriate calculus-based justification for the fact that g is concave up? And this is where most students kind of freak out because you feel like you're not given much at all, and there's multiple layers of things you have to process. So let's kind of walk our way through it and talk about it. G concave up, okay? AJ, the fact that it is asking about concave up, do you remember where we have to look to find concavity? Oh, that's all right. Yeah, that's no problem. Okay, good. Nope, you're right. You're right. Okay, so G, we need to figure out G double prime somewhat. Okay, so G of x, we were told is the integral of 0 to x f of t dt. G prime would be the derivative of the integral. So G prime means this integral symbol cancels off, and we've got to plug x in place of t. So G prime is f of x times d of x, which is f of x. Okay, so G prime is the graph. G double prime would be derivative of graph. So we're kind of using a lot of our different reasoning skills of things we've learned. And that's why a lot of students, these questions are just out there. Bella, do you remember how we figure out a derivative by looking at a graph? What does derivative stand for again? It is. But if I'm looking at a graph, how do I figure out the derivative from a graph? Because we don't have equations. Do you remember what derivative is? Do you remember what derivative is AKA for? And if you don't, that's okay. Well, that's all right. That's why we're trying to talk about it. Does anybody remember what derivative is? This is when we very first learned. Yes. Yeah, perfect. Derivative is slope, because if you're looking at a picture, it's going to look like slope. Marissa, what do we know about the slope of this picture? Uh, yeah, yeah. I mean, like what you were saying was true. The only thing we know about it is it's positive because it's going up. So we have a positive second derivative. So looking at this picture, we know the second derivative of g would be positive. A positive second derivative means concave up. So this would be the calculus-based justification that it's concave up. So you're going to have to, you can do this reasoning in your head if you want. You can certainly write things down like I did if it helps you keep track. But that's how you do these calculus-based reasoning questions that are part of your homework for today. And they're all going to be different. So this is difficult for me to give notes on and for you to write notes on because they're all completely different. You're just going to have to use calculus knowledge on these to figure things out. So this is the graph of f. Let g of x equal 0, integral 0 to x of f of t dt. So I'm just going to start writing stuff down again. So I've got g, the integral from 0 to x f of t dt. So g prime of x, I don't even know what the question is yet. G prime of x, the derivative of the integral would give me f of x times the derivative of x, which is 1. So g prime of x is f of x. Well, now let's look at the question. Oh yeah, the graph. The graph is not always going to be the derivative like this. I just, for these two problems, it was. What is an appropriate calculus-based justification for the fact that g has an inflection point at x equals c? Oi. Well, inflection point information comes from second derivative. Okay, the derivative of the graph is the slopes of the graph. Okay, now we have to rely back on our knowledge that we knew. Who have I called on? Jacob? Do you remember what an inflection point means? Okay, or negative to positive, but yes. So an inflection point happens when second derivative is equal to 0 and when the second derivative alternates concavity. So the concavity is positive, negative, or negative, positive. So if these two facts happen, then that's an inflection point. Second derivative equal to 0. Well, that would mean the slopes of the graph are equal to 0. And second derivative alternate concavity would mean the slopes before and after this would be different. So this one says an inflection point at x equals c. Conveniently, x equals c has a slope of 0. Okay, check. Alternate concavity. The slope before and after is different. Negative slope. Positive slope. So the concavity, because the concavity is represented by the derivative of this graph, alternates. That would be our calculus-based justification. So this is the kind of reasoning you guys are going to have to go through to answer these questions. They're not necessarily hard, you have to keep facts straight. That's going to be the hard part for most. I'll do another example here and then we're pretty much out of time. I apologize that you're going to have work outside of class, but that's kind of understood at this point too. And we've slowed down a lot, so you haven't had much homework at all this week. This is the graph of f. Let g of x equal integral 0 to x f of t. So it looks like once again our graph is the first derivative. So g of x is the integral 0 to x f of t dt. Okay, it isn't always like this, but maybe your homework today it is. So g prime of x would be the derivative of the integral, which is going to be f of x times the derivative of x, which is 1, so f of x. So our graph is g prime. What is an appropriate calculus-based justification for the fact that g has a relative minimum at c? Oy. Okay. Relative minimum is what we need to bring back facts about. Kenzie? What happened to Ken's? Ken's? You changed it to Kenzie now. Oh, all right. All right. Well, hopefully you're awake enough to answer this. Do you remember how we find a relative minimum? Good. No, very good. So it's from the first derivative. It has to happen at a critical point. So that's where the first derivative is equal to 0 or undefined. And it has to have slopes, or first derivative is changing from positive before, negative after. So that was like our sign charts, where the first derivative was positive before, first derivative was 0, first derivative is negative after. That's a relative minimum. So our whole thing is focused on this graph. This graph has an answer of 0 at c. So that means g prime is equal to 0 at c. So that's a critical point, critical number. And g prime is positive Oh, I said this one wrong. I wrote the information for relative max. Ugh. You guys are supposed to yell at me. Relative max is positive before, negative after. Relative min is negative before, positive after. I need more coffee and tea, I guess. I'm mad I wrote that down. Okay, so we want to know that the first derivative is negative before, positive after. Well, first derivative is negative before because the first derivative is this graph. So it's negative before, positive after. And so then that would be the calculus justification that this is a relative minimum. The big deal on these questions is you just have to remember details of what things, how you find things. And then you have to try to do it from that graph. It's not easy. They're just They're slow. They're very slow. So don't try to rush through these. Okay. Well, we actually made them within an hour, so I'm kind of happy. I wasn't sure if I was going to be able to give all that in the hour. The information today isn't horrible. It's just lots of information shown in strange ways. So that's why that's why they're AP questions, because they want to know you really know what's going on. Okay. Well, we're done. Try the homework for these topics in Khan Academy. I believe it's 4 assignments. Yes. The first assignment is on the graphs for area. The next 2 assignments are for the fundamental theorem of calc. And then the 4th assignment is on these questions. So it's the next 4 assignments. All right. Thank you guys for coming today. I will see you Monday. Yeah. You bet.